Here is Soho Lasco C2 and C3. And you can see Mercury sliding through the frame there. We'll also show stereo A. Ah, yes. And by the way, this right here is part of the reason why we have not been streaming to Twitch, because the connection keeps shutting the fuck off. And I'm starting to get a little bit pissed off about it. So, yeah, all right, wonderful. Here is the view from stereo A, located over here on the left. And we show this to show its location as it's overtaking Earth. It's got a very low amount of angular difference to Earth's view, which makes it unuseful for helping with coronal mass ejection trajectory. However, sometimes the other coronagraphs are missing data, so it is still helpful there. Let's take a look at our custom coronagraphs. That is 24 hours Soho Lasco C2, C3, and the SDO 304 angstroms wavelength. And we'll get a little bit closer. Those CMEs look like they'll miss Earth to the southeast. Here's an even closer view. And we're back to 304 angstroms. Moving right along to the filament situation. So we're looking at the El Teide, Spain ground-based solar observatory here. And massive filaments, especially in the southern hemisphere, but also in the northwest. So this one could be named. And if you want to name filaments, well, we are on Twitter. Follow the hashtag #NameThatFilament. This one will be named today after a living person. And if you'd like to decide what living person that filament is named after, you got to do it on Twitter. Despite the ridiculous nonsense of Elon Musk. Did you know that you've now got a tweet allowance? Yeah, you've got a tweet allowance, folks. You can only see so many tweets because Elon doesn't know what he's doing, and he does not understand how to consider unintended consequences. He has no idea what he is doing. Elon Musk, not an engineer, but he appoints himself as one when he purchases companies. So here is the GOES 18 SUVI. And check out that crown prominence, especially the northern hemisphere, the northern polar one. That's pretty sweet. And this brings us to our bonus features. First bonus feature is charging hazards, and we've got some internal and surface charging hazards there. The internal charging hazards are over the central Indian Ocean there and Oceania. Surface charging hazards are in the central Pacific, and surface charging hazards are caused by low energy electrons outside of spacecraft. Internal charging hazards are caused by high energy electrons getting inside of internal circuitry. So we could see some minor communications failures as a result of those. The GOES electron flux here showing up, just peaking back into warning levels here, surprisingly high, and that's partially because the CME impact was surprisingly weak. Well, not really surprisingly weak, just weak. Weak as forecast. I mean, we said, what, a 30% chance of impact. There's the one-year graph of the relativistic electrons that we just showed, as measured by the GOES 16 and GOES 18. There is the forecast model, and no arguments there. That's NOAA's forecast for the electron flux depicted by the green boxes. The yellow diamonds are the observation. We'll also show the F layer of the ionosphere because you never know when the data will show you something important. It's the bridge between Earth and space at about 300 kilometers of altitude. Here's the vibrational frequency therein, the F ionosphere. So that's what's going on. And if that's Greek to you, don't worry. We'll show the anomalygram as well once it plays through one more time. So here's the anomaly in megahertz from a 30-day median. Nothing too crazy there going on in the ionosphere. And had we seen a more significant coronal mass ejection impact, there would be more significant anomalies in the ionosphere. But based on what actually happened, not. Anyway, there's a latest image, 1300 universal time ionogram and 1300 universal time anomalygram. We'll also show the total electron content forecast. It depicts free electrons to about 12,500 miles of altitude, the altitude of your GPS satellites. Located in the inner portion of the outer Van Allen belt, it has to communicate through the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Those free electrons cause signal refraction, which is what is depicted here. The total electron content forecast showing electron counts. Those red areas are the most likely places to see GPS errors, and we are seeing some anomalies here in the southern hemisphere. Places like the Southern Ocean, also nighttime anomalies happening there, which, by the way, is more common when we have the magnetosphere attempting to reach static equilibrium. You'll see those nighttime GPS anomalies happening there. No real surprises there. It's just the system attempting to reach static equilibrium. That's your total electron content forecast. The coupled thermosphere, ionosphere, plasmasphere electrodynamics. Here's the anomaly from the 10-day average for North America. It depicts high electron count anomalies in red, low electron count anomalies in blue. And if we were able to use the data to forecast earthquakes, this is where we would start. Not sure yet. We're more interested in cosmology because, well, there's a lot of stuff to advance when it comes to science. Anyway, here's the latest intensitygram and latest colorized magnetogram. We press refresh so you see that it's the latest. And check it out. That sunspot group's got deltas. So there's some magnetic shear there, and of course just the proximity to the limb increases the likelihood of it producing a large solar flare. These groups down here are also interesting indeed. Whoops, there we go. So there are a series of sunspot groups in the southeast. And this one here will get a name also, as long as it stays intact. So we've got at least 2 new named sunspot groups coming today. I don't know how this one hasn't gotten a name yet. It's been there for days, but it will get a name. And the sunspot number will be pushing 200 once again by the end of the day today or tomorrow. That brings us to our meteorology segment. And we're going to show you all kinds of stuff about Earth's weather from a global perspective. First, our paid affiliate / sponsor. Yeah, our paid promotion. So one of those is the Hemp Lucid. The other is the Amazon shop. Of course, we've also got a Redbubble shop and our own subscription services site. So check out the links below the video to the Hemp Lucid shop and so on. The most popular products there are the CBD water-soluble tinctures, but lots of other good products there as well, like the Focus Mushroom Gummies. You can also find sleep and stress gummies and body balms and all kinds of other splentacular products there from hemplucid.com. Again, links below the video. You can also find links on our homepage there. So check those out. And we've moved on to show both the hottest and coldest part of the planet in one image. So the hottest place in the world here is in Iran, actually. Right in here, it's like 120 degrees. 122.6 there in Iran. Coldest place in the world, not surprisingly, as it is wintertime on the highest, driest continent. How about negative 90 degrees? That's on the cool side, I'd say. It may be a little bit inhospitable there in wintertime on Antarctica. By the way, it is definitely on my bucket list to visit Antarctica. I don't know about wintering there. That is for only like a half a dozen people winter in Antarctica. And let's move on to our regular meteorology segment here. Here are the surface winds of the east. Strong low here southwest of Australia. Jet streams of the east looking like this. Jet streams of the west depicted and the jet stream over the U.S. is getting a little incoherent. In the coming days, you can expect to see that. Some weird weather patterns will be returning to the U.S. There are the surface winds. Here are the surface winds of the central world. And here are the jet streams, blowing backward over North Africa and the northern Indian Ocean. So here's our temperature. Once again, we're showing the temperature on windy.com. Over 120 degrees there. That's the hottest part of the planet. We've got a bunch of high temperature warnings in the southeastern U.S. We'll get the forecast for that in a minute. Here is the clouds and fog scenario over the western world. Some equatorial cloud bands showing up there. As convection is kind of important to drive weather features. Next, your smoke forecast. That map is smoking. If you want to view it yourself, it's firesmoke.ca. And it looks like the smoke is going to subside here for most of the U.S. here. It's all pretty light. That's depicting the 2.5 micrometers per cubic meter particulate count. The PM 2.5, particulate matter 2.5 micrometers and smaller. Here's your weather.gov map. We do have some air quality alerts there around the northern Great Lakes. However, again, those are looking like they're going to be subsiding here. If your location is lit up, click your location. Lots of red flag and hot weather warnings there for the U.S. And here's your temperature forecast, since it seems to be the feature to cover. Temperature. That's a GFS 72-hour temperature forecast in degrees Celsius. It's a temperature anomaly in degrees Celsius, that is. Here's pressure and precipitation. The same model, the GFS 72-hour, and some extreme weather here coming to South Dakota and Nebraska and Iowa, also southern Minnesota. You're on blast. Those storms might not be a blast. You could see some damaging wind, hail, and tornadic activity from those. Next, lightning. That's what's been striking for the past about 10 hours. And here's our real-time lightning map next. You got terrestrial strikes. We do have some minor thunderstorm activity here. The most significant looks like it's north of Knoxville. Those are fairly mild thunder showers. There's the full map view from lightningmaps.org. If you enjoy the content, press like and subscribe. Tell your friends and foes about the channel. And consider becoming a member of the Smash Team if you'd like additional content. We built our own subscription services site to replace Patreon, although we still are on Patreon, because we needed additional capabilities. So we've got them. Smash staff built the site. So if you want to give her a raise, consider becoming a silver or gold level member of the Smash team. Links on the homepage at smashomash.com. Once again, congratulations on realizing the channel exists. And welcome to the Neo-Renaissance. Did you know we're composing a paper that explains the likely mechanism underlying the solar sunspot cycles? It's pretty serious. Smashomash.com is the official homepage that we are using to support this new science endeavor. We'll close out the video with Doppler radar, and we'll briefly show the full 50-state view. A little bit of precipitation there in southern Alaska and central Alaska. Here's a view of those thunderstorms around Louisville. Actually right over Lexington here and moving toward Charleston. We'll focus on the lower 48. Here's the clouds and fog scenario. And here is the water vapor map. So that's what's up. There is your recap. Doppler radar depicting vertical motion in the air column. These ground-based systems are what people usually look at when it comes to weather, but to get additional clarity, there is the clouds and fog scenario. And the most clarity, if your Doppler is unclear, will come from the water vapor map. Hopefully we've been clear. Hopefully you're not frightened of space and Earth weather, and hopefully you're able to forecast it yourself, as again, we empower our viewers. We don't attempt to gaslight them and fill their heads with nonsense. So hopefully your head's not being filled with nonsense. And it looks like it's time for me to head back to the bunker before, something spooky happens in space, a frontier. Anyway, while I'm gone, may that solar wind be at your back.